Okay, so is square root of 2 a fraction? Or a rational number? So is it a over b equals square root of 2 with a and b integers?
Well,
So, like, is it 9/8 or is it 211 over 53 or something like that?
well, what we could try to do, well, we did the continued fraction for it.
Oh, hey! Maybe we could look at it as a continued fraction.
We said it was 1
This is
plus
probably not what the Greeks did, but maybe. We said it was what? Do you remember what it
1
was?
plus 1 over 2 plus 1 over 2 plus 1 over... And this goes on forever.
So we said this was the continued fraction. And we started approximating just by stopping at various places. So the first approximation was just 1.
1,
But we know it's not exactly equal to 1 because
we know
what's the square root of 2 squared?
it's 2.
It's 2. What's 1 squared?
1.
1. So the next approximation was 1 plus a half.
1 plus a half is 3 halves.
So square root of 2 is approximately 3 halves. Is it exactly equal to 3 halves? Maybe we solved the problem.
No.
Why not?
Well, well, if you multiply that by 2, you get 4, and it's not.
Well, we don't want to multiply by 2, we want to square. So
Well, if we
square root of
square
2 squared
it,
is
well, it's 2.
2. What is 3 halves squared?
3 halves squared is, it's 9 fourths.
9 fourths. Is
So,
that 2?
No.
No. Is it bigger than 2 or is it less than 2?
It's a little less than 2, because 8 fourths would be 2.
8 fourths is 2.
So it's more than.
A little bit more than 2. So this is a little bit more than 2. So that means 3 halves is greater than the square root of 2. Up here 1 we know is less than the square root of 2 already.
And then we saw, and now, well,
We could continue.
we could continue, but this fraction goes on forever, and the approximations keep getting closer and closer.
They do keep getting closer
But
and
it'll
closer.
never reach. It'll never reach. Otherwise, the continued fraction would end.
It would, you're right. It would never reach it. If this continued fraction ever ended, we would have found a fraction. Let's do a couple more approximations though. What is 2 plus a half?
2 plus a half we just saw is 3 halves.
So this is 1 plus 1 over 3 halves. What's 1 over 3 halves?
It's 2/3.
So 1 plus 2/3. And what is this?
It's 5/3.
Square root of 2 is approximately 5
So we get
thirds.
25. Wait, we get.
Sorry, not 3 halves. 5 halves. My mistake.
So 2/5.
2/5. Sorry about that.
So you get 7/5.
7/5. That's better. So this, square this, I get 2. Square this,
You get 49 over 25.
jeez, I can't write
So
today.
it's really close.
Is this bigger than 2 or less than 2?
Well, 50 over 25 would be 2.
Yeah.
So it's a little less.
It's a little less. 7/5 is a little bit less than the square root of 2. So the interesting thing about these continued fraction approximations is that they alternate between being too big and too small. So too small, too big, too small.
Too big.
The next one, if I remember right, is 17/12.
So it's 189 over 289 over 144.
289 over 144. And this is bigger than 2 or less than 2?
It's going to be bigger than 2.
Because 288 over 144. So this is bigger than the square root of 2. So they alternate. So not only do they get better and better approximations, they actually alternate between being too big and too small.
Cool.
Which is pretty interesting. But your observation is right. When we calculated this continued fraction,
It goes on forever.
it actually never stops because the split, flip, and rat just keeps going with the same thing every time.
Yeah.
So this gives us a hint that the square root of 2 is never going to be exactly equal to a fraction because otherwise the continued fraction would stop. So that's a very good observation by you. The continued fraction goes on forever, therefore it cannot be
A fraction.
a fraction. Let's see if we can find another idea, okay?
Okay.